we start with the question of how do we define a parabola, okay? A parabola is the set of all points that are the same distance from the focus and the directrix. Try to respell that. From the focus and the directrix. Now I know what you're thinking right now. You're thinking, well, what the heck is the focus and what the heck is the directrix? I'll show you that example here in just a second. You're used to that shape. If it's horizontal, it looks different. It's x equals a times y minus k squared plus h. So now we don't just draw vertical parabolas, we draw horizontal ones. You tell me what changed in the equation. X and y changed, and h and k changed. Now here's the deal. The vertex is hk. Do you see how h is paired up with the x? That means it's the horizontal shift. Okay? In this situation, k is paired up with y. So that is the vertical shift. So the vertex is still hk. Just people get confused. They look at it and they look at the inside. They see y minus k. So they're like, well, a lot of people think that the vertex is going to be kh, but it's not. This refers to the vertical shift. Okay. Let's actually draw a graph of the first one and start to list some of the characteristics. So if I have a vertical parabola that looks like this, you guys are all familiar with this spot, which we call the vertex. One other piece that you're familiar with about the parabola is the axis of symmetry. Is the axis of symmetry going to run vertical or horizontal in this situation? It's going to run vertical. What is the equation for a vertical line? X equals or y equals? X equals. And what is the x value that it runs through? H. So that's your equation for your axis of symmetry. The direction of opening. If that front coefficient is positive, it's going to open up. If A is negative, it's going to open down. Everybody okay with that? That's all stuff that you've seen before, correct? Let's look at the new stuff. The focus and the directrix and the length of the lattice rectum. Very awkward piece of language to work through, but we'll talk about it, okay? The focus sits on the inside, and here's the deal. It sits p units away from the vertex. The directrix sits on the outside. It's an imaginary line, and it sits p units away from the vertex. Now you're wondering, what? How do you find p, right? This is a very important equation. A equals 1 over 4p. That will help you find p. The lattice rectum happens to be a segment. That's what the word rectum actually means, segment. Kind of matches, doesn't it? Yeah. Okay. And lattice means kind of stretched across. So in this situation, you can see that the lattice rectum, it stretches across the focus from side to side. The lattice rectum is actually that segment that tells us how wide does the parabola go. Okay? Now, what we want to do is we want to actually write an expression that can tell us the location of the focus. Well, from the vertex, I move up p units. So will that change the x value of the vertex or the y value of the vertex? The y value. So the focus still has an x value of h, but I'll take k and I'll add p to it. The directrix is a horizontal line. A horizontal line has an equation of x equals or y equals. Y equals, that'll be k minus p. And length of lattice rectum, because we're talking about length, we use the absolute value sign because we say length is not negative. So it's the absolute value of 4p. A lot of information, huh? So what we're going to do is we are going to turn to the next page, and we're going to do an example together now. And we're going to list all these characteristics, and we're going to sketch a graph. Are you worried about trying to remember this for the test? So let me show you exactly what you'll get for the test. You have two options. Number one, you can use the sheet that I put together for you. You can't have examples, but you can have the information written down. See the difference? So you can see that's a parabola. This is going to be for ellipses, which includes the drawing here. And then this is included for hyperbolas. If you would like to make your own because you find this difficult to read, you are welcome to do so. So a lot of people, what they'll do is they'll take this section right here and they'll rewrite it. Or they'll cut it out and they'll paste it onto a sheet of paper. You get one sheet of paper, front and back, that has these type of notes on it. You understand that? The reason why I give you the option is one time I gave the students the very last page and somebody said, well, I don't like this. I'm like, oh, fine, memorize it. I'm like, well, why don't you write one for us that we can understand better? I was like, well, write it yourself. I mean, so if you don't like the back page, that's fine. I totally understand. I don't care for it either. I'd prefer to do it from memory. But if you would like one that looks better, go ahead and write one on your own. That's what most students do. I would say about a third of students choose to use the one I have on the back. Okay. All right, so let's sketch a graph of these and identify all the characteristics. It's a parabola, and so we're going to have a direction. We're going to have a vertex. We're going to have an axis of symmetry. We're going to have a focus point. We're going to have a directrix. We're going to have the length of the lattice rectum. And those six will be able to produce for us an excellent, excellent graph of a parabola. Let's start with the direction. Do you think this is a vertical or horizontal parabola? Vertical. How come? Because it's y equals. Y equals. So if it's y equals, it goes vertical. That means it's either go up or down. Is this one going to go up or down? It is going to go up because it's positive. Good. So we've identified direction. Any question about that? We move on to the vertex. Everybody should be able to look at this and tell what the vertex is. Good. And no. The 1/8 will affect how wide it gets. It's not going to affect the location of the vertex. Excellent question. Two types of people. One type of person decides to list all of these and then graph it. The other one graphs them as they list them. I do the second. It's much easier in my opinion. So once I start to get the vertex, I start plotting points. I have -2, +3. That's my vertex. Instead of coming up with the axis of symmetry, I draw the axis of symmetry and I name it. Is the axis of symmetry going to be a vertical line or a horizontal line? Vertical. because it opens up. It's a vertical parabola, so a vertical line will split it in half. What is the equation for that axis of symmetry? Now that I've drawn it, let me name it. What is the equation? X equals -2. Very good. All of this is from, this is review so far. Now let's do something new. For these last three, I need to find what value? P. I have A equals 1 over 4P. What is my A value? 1 over 8 equals 1 over 4P. Solve by cross multiplication. 4P equals 8. P is dos. Spanish for 2. Okay? So if P is 2, what does that mean? What do I do to locate the focus? I move 2 points towards the inside of the parabola. So I'm going to go up 2. Red here. What is the location of the focus? Do you guys see that I plotted it and then I named it? I think that's easier. If you want to name it and then plot it, go ahead. I find that more confusing. The directrix, I'm not going to go 2 units up. I can move 2 units. And is it a point or is it a line? It's a line. It always runs perpendicular to the axis of symmetry. I've drawn it. Let me name it. Is it x equals or y equals? Y equals, what's the y value goes through? 1. Length of the lattice rectum, absolute value of 4 times p, which is 8. That means that segment is 8 units. It reaches from one side of the parabola over to the other, and it goes through the focus. So what I do is I do 4 units on one side and 4 units on the other side. So I have 1, 2, 3, 4. So that's going to be one side of the parabola, 4 units over, and then 1, 2, 3, 4. And I have 4 units on the other side. Whoop. Did Will answer your question? He's a smart man. So it's 8 units, so I went 4 on each side, so it's a total of 8. This gives me a really good indication then of how I draw my parabola. I start at the vertex, and I run through those endpoints of the lattice rectum. So did you even use your directrix in order to draw the shape? No. So here's why I like to draw the directrix and why you're required to. It helps us to remember the meaning. If I select a point on the parabola, it should be the same distance from the focus as it is from the directrix. Better, huh? Like, that was pretty bad up there. But that's closer. Those 2 green lines look like they're close. And that's what it means to be a parabola. Okay? That's what it means to be a parabola. Okay, we're going to do one more example today. Let's flip it over to the other side. Tomorrow we'll do 2 examples. You have about 25 minutes to work in class. And here we go. Let's now look at a horizontal parabola. We understand that this is the general shape. Where that is HK. So now I want to do the axis of symmetry. Is the axis of symmetry going to run horizontal or vertical? Horizontal. How come? Yeah, because it splits it in half. If it's going to split it in half, it's going to have to run sideways. So is that an x equals or a y equals? So y equals, because it's a horizontal line. And what's the y value that it runs through? Goes through k. The direction of opening, if A is positive, it's going to open to the right. And if A is negative, it's going to open to the... Is everybody okay with that? That's new, right? Okay. All right. In order to figure out P, we still use A equals 1 over 4P. But the deal is that it's going to sit P units on the inside for the focus. Okay, so this distance right here is P. So if I move P units from the vertex in that scenario, is that going to change the x value or the y value? It changes the x value. So therefore, it's going to be h plus p and then some k value. The directrix is going to sit p units on the outside. And it's perpendicular to the axis of symmetry, so therefore it's a vertical line. Is that going to affect the x value or the y value? X value, it's an equation of x equals, and it's going to be h minus p. The length of the lattice rectum remains the absolute value of 4p. Liz has exceptional handwriting. She's also using multicolors to help her out. So she could definitely cut this out and place it onto a sheet of paper to help her for her notes for her test. However, some people also ask for a second copy of the notes so they can rewrite them, make them look even nicer. So it doesn't matter to me. I'm just telling you what students have done in the past. Okay, flip it over. Let's look at this second example. We have 2x is equal to y squared. Horizontal or vertical parabola? Right. Would you like to solve for x or for y in this situation? Yeah, we want x equals because the y is being squared, correct? So when you solve for x, you get x equals 1/2 y squared. So if it's an x equals, is it horizontal or vertical? It's horizontal. This is a horizontal parabola. I think the dead giveaway is we're used to seeing x squared, correct? That's a vertical parabola. When the y is squared, that's a horizontal parabola. Let's list our features. We have the direction. We have the vertex. We have the axis of symmetry. We have the focus. We have the directrix. And we have the length of the lattice rectum. And there we are. Let's start with the direction of opening. Very good. How come? It's positive. Very good. The other two classes haven't picked up on this one as quickly, but the vertex, zero, zero. If it was x equals 1/2 times y minus 3 squared plus 2, anybody know what the vertex would be in that situation? 2, 3. The y value can be found here. It switches, right? You're used to looking at it saying 3, 2, right? But it switches. The y value is paired with the y, okay? So keep that in mind. I'm trying to share with you things that people have made mistakes before on tests, so hopefully that helps. Okay, so I'm going to start plotting this. Well, I got 0, 0, and it opens that direction. So is the axis of symmetry going to run horizontal or vertical? Horizontal, so it runs right along the x-axis. So what's the equation for the axis of symmetry? Y is equal to 0. Very good. So again, that's hopefully all, basically review for you other than the direction. In order to figure out these three, what do I need to do? I need to find P. What's my equation for P? What is my A value? And I get 2 is equal to 4P. Divide by 4. 1/2 is equal to P. A lot of people wonder, Mr. Gens, how do you know how big you should make your graph? I usually make my graph, 4 times bigger than P. So if P was 1/2, then I need a 2 by 2, right? And really, 2 units from each part of the vertex. So if I go 1, 2, 2. I think that will be sufficient. Okay, let's locate our focus. One half 0. It's okay. There you go. And that's the mistakes that people make when they try to come up with the location before they plot it. I really encourage you to plot it and then name it. So for the directrix, I'm going to move half a unit back and draw that vertical line. Now that I have that in place, let's name that vertical line. What is it? Yep, x equals -1/2. The length of the lattice rectum, absolute value 4p. 4 times 1/2, 2. So from my focus, I'm going to move 1 unit in each direction for a total of 2. I moved a 1 up and 1 down for a total of 2. I would really love it if this was, if I pick a point and it's equidistant. I'm going to try. Got that one. And I've got that one. Are they the same? Let's be real critical here. I'm gonna take my selector and grab that guy and tilt it sideways. I'm gonna. Oh no! Come on over. It's taking a lot of practice. Thank you. Take donations on the way out. So that again, I just do that to show you that's the definition. That's the reason why the directrix exists. So this is going to look confusing. I'm going to try to make sense of it. Here's how your book chooses to teach. You're not going to get a new assignment tomorrow, okay? This is what you have for tomorrow as well as for the weekend, okay? So really try to work on this through Monday and you're okay. Your book tells you to do parabolas in 9-1 that are all centered at 0, 0. And then 9-2 is ellipses at 0, 0. And 9-3 is hyperbolas at 0, 0. And then it takes 9-4 and it shifts them all. What I choose to do is say, hey, let's talk about parabolas all together. Let's talk about ones that are 0, 0 and ones that are shifted. And then we'll do ellipses at 0, 0 and shifted, and hyperbolas that are at 0, 0 and shifted. So I think that's going to help you. I've tried both ways, and I do think that this is better. So you have 5 that are at 0, 0, and you have 3 that are shifted. I encourage you to try to come to class tomorrow with 2 or 3 of these done, and then you'll have about 25 minutes in class to work on the other pieces. We'll simply just finish up the other 2. We all good? That's one assignment. You will not get a new one tomorrow. That is one assignment, just the way the book's structured. I have to break it up like that. I have the pages sitting on my computer. I'm going to upload them to the website right now.